Hello, welcome to this video series on MDX for SQL developers. I'm Nasir Ali Mirza at DoSQLBI.com. This is the next video in MDX for SQL developers. In this session, we will cover the joins. This series is about building the MDX skills in SQL developers. In the previous sessions, we have seen OLTP database and its comparison with the OLAP database. We have covered MDX terminologies and what we put together as MDX language rules. This video is about joins in MDX. We will see how MDX joins are different from SQL joins. We'll see what do we mean by implicit joins in MDX queries, and we'll see what happens when the query uses joins in unrelated objects. Lastly, we'll see the cross joins in MDX. Let's start with an example how MDX joins are different from SQL joins. Let me switch to SQL Management Studio. Let us start with an example about it. I'll switch to SQL Management Studio. What you see is a SQL query. This query uses dim product table and joins that with fact reseller sales, and then it also joins with dim sales territory, and there is an join mentioned between these three tables, and we restrict the product to type cable lock, and then it is grouped by the sales territory country and English product name. Let us run this query. What we get in the result is territory country names, product name, we had restricted it to cable lock, and we get the amount. Now I'm switching to the MDX window. This is connected to again AdventureWorks. I have an example here as well. What I have here is I am referring to dimension sales territory, which is this, and in that I am using the attribute sales territory country, which is this one, and I'm also referring to another dimension which is product, and in that the product attribute, and I'm confining that to cable lock. These two dimensions are referred in a tuple that is on axis 1, and on axis 0 I am referring to reseller sales amount. Now let me run this query. When I run this query, the output I see is sales territory country name, and then the product name, and then the reseller sales amount. Same as what I see as an output of my SQL query, with the difference that my MDX query is also showing me countries where there is no sale, no reseller sale. Now if you again observe, in a SQL query we explicitly mention these joins between the tables. Now in my MDX query there are no joins mentioned anywhere. So how is MDX query able to figure out what tables are to be joined based on what keys to produce the data? Now this is how MDX queries are different when it comes to joins. In MDX queries, the joins are mentioned as part of the database design. Let me switch to Visual Studio, where I have connected to my local AdventureWorks database, and I'm going to open the Cube AdventureWorks. This is the design view. So here there are various tabs that you see out here, one of which is dimension usage. Now in this dimension usage, here is a list of all the dimensions that are part of this. I can scroll down and see more dimensions, and I have the major groups starting with internet sales, internet orders, internet customers. I can scroll right and see more major groups. Major groups, as we have seen in the past, they normally are mapped with the transaction tables or fact tables in the underlying database, and these dimensions are the lookup tables. Now let's for a minute come back to the query that we just saw. I'll go to the MDX query. Now what I'm using here, I'm using reseller sales amount, and they are joined with sales territory and the product. Reseller sales which is this major group, with product, that is this, and sales territory. Coming back to this, so this is sales territory, this is product. Now if I go to my SQL statement, my reseller sales is joining with the product table on the key. My product table is joining with the reseller sales on the product key. And I'm coming back. I want to see how is this relationship mentioned as part of the database design in analysis services. Now here what you see is it is defining the relationship type is regular, granularity attribute is product, dimension table is dim product, and major group table is fact reseller sales, and here it mentions the keys on which they are joined. So the join statement, which in SQL query is mentioned here, inner join and the keys that are joined, that it is joining on, which becomes as part of this query itself. In analysis services, it becomes as part of the database design, analysis services database design. Let us see the second one. Besides dim product joining with the reseller sales, we have a join between fact reseller sales and the sales territory, and they are joined on the sales territory key. I'm coming back to this Visual Studio. I have a sales territory which is joined with reseller sales, and let us see what that relationship is. Again, relationship type is regular. There are many other types of relationship that you can define in analysis services database design, and the granularity is a region, and dimension table name, fact table name, and then there is the key name is defined as part of the database design. So that covers this relationship. Now when I come back to the equivalent MDX query, I don't define anything about the joins. I don't say how sales territory needs to be joined with the majors group where reseller sales amount to the fact table to which this is one of the column of that fact. I don't mention how product relationship has to happen with the reseller sales fact table. So that is what is implicit joins. Analysis services picks up those joins from the database itself, as that has been defined as part of the database design. So when I run this query, I get the results same as when I run the SQL query, which has all these joins defined. Again, notice here we define in the where clause what product name we want to look at. In the MDX query, that is mentioned as part of the syntax here with the attribute product. One last thing, in the SQL query, we are grouping the results with sales territory country and English product name. In MDX query, whatever is mentioned as part of the tuple on the axis, it by itself is already grouped on that. That is a very quick view of comparison between SQL joins versus MDX joins. Let's see some more examples of MDX joins. Now this is another query. You saw in the previous one, I still have the result set here. The result was also showing me these null values. The example that I have right now, I am using this having reseller sales amount not equal to null. Let me run this query. What do you see? You see that we are still seeing these nulls. Okay. Now what I am going to do is, let us pick up this statement here, cut it from there, and I paste it here. Now I run it again. Now what do we see? We see that all those nulls are taken away. Why? Because we had added in the previous example this filter condition on axis 0, but the nulls, those rows were produced on axis 1. When we moved that condition to the axis which was producing the rows in this result set, it is now filtering properly. We can achieve the same result in a different way as well in MDX. Let me comment out this, and all that I'm going to do is, now first let me run this query again. We again see these nulls coming in, and what I'm going to do now is I'm going to add non-empty as another keyword. When I run this, I again see those empty rows not present. Let's continue with some other examples that we have. In this query, we have taken product attribute and the reseller sales amount to axis 0, and we left only sales territory country on axis 1. Let's run this. Now, instead of 3-column output, we are getting 2-column output. So this is just to demonstrate that how we can use the query differently to produce the results set in a shape and format that suits our requirement. I have another example. Now in this one, we moved sales territory country and the product to axis 0 and have a condition there as well, and kept reseller sales amount on axis 1. Now what you see below is the output of the previous query. Let us see how this query produces the output. So it did what in SQL we may know as unpivot. Earlier we had done a pivot. This is the flexibility and the power of MDX queries. To continue on the examples, this is another SQL query which is using fact internet sales, dim product, dim subcategory, and dim category, and there are explicit joins between them, and I'm using the aggregation function sum for order quantity. Because I'm using this, I have to group by on all these columns that I'm using here. So we group by category, subcategory, and product name. And to see the results in a particular order, I'm also doing the order by on category, subcategory, and name. Let us run this query. So when we run, we see a list of product category, and then each product in that category, the product name, and then the quantity. So I can say accessories, bike racks, and then the product hitch rack 4 bike, quantity is 328. This is internet sales. I have the equivalent of this SQL statement in the MDX. Now see the simplicity of this query. We are just on axis 1, I'm listing all my dimension attributes that I want to see the result by: category, subcategory, product, and on another axis, that's axis 0, we are putting internet order quantity. As we saw previously, it would automatically do this group by on each of these attributes, and it would implicitly figure out the joins between all these 4 tables that are involved. So we get the same result here that we had seen in the SQL statement here. This is another interesting query. What you see in this SQL query is I'm referring to dimension reseller, dim geography, and dim and fact reseller sales. What I want to see is something from the geography table, which is country region name, and I want to sum up the order quantity. Now in this case, my geography table doesn't have a direct relationship with the reseller sales table. So I start that's where I'm using dim reseller. So I join dim reseller to dim geography, and then dim reseller to my reseller sales, fact reseller sales. Let us run this query. So I get a list of country names and order quantity of that. Let us see what is the equivalent of this in MDX. It's simple, straightforward. I'm saying geography.country and on axis 1, and on another axis I'm referring to that measure which I need, that is reseller order quantity. Let us run this query. So output is again same. I see a list of countries and I see reseller order quantity. Now in this MDX query, we know that there is no relationship in the database directly between geography table and the reseller internet sales table, the reseller sales table. Let us go to Visual Studio and see how our relationships set up in this case at the design time in Analysis Services database. Let me switch to Visual Studio again, and we have to see reseller sales and geography. See, this is the relationship that we want to see. As we saw, geography is not directly related to reseller sales. We have an intermediate dimension. Let us see what that is. So this is another relationship type which is called as referenced relationship. In this referenced relationship, there is a reseller as an intermediate dimension. So as an intermediate dimension, I'm using reseller, and then I'm giving the key names, that what the intermediate dimension key is and what the reference dimension key is, and then that way that relationship is defined. So when it comes to execution of the query, my query becomes as if they are naturally related in a relationship between the geography table and the reseller sales table. And when it comes to the SQL, I have to define all those intermediate relationships in my query. Let's switch back to our presentation. So this again kind of showing here what we just saw in Visual Studio, how the relationships are defined as part of the database design in analysis services. So that covered our SQL joins versus MDX joins. So we saw how our SQL joins different in comparison to MDX joins, where in SQL it becomes part of the query, and in MDX the joins are described as part of the database design. We saw the implicit joins in MDX query. I'm Nasir Ali Mirza at DoSQLBI.com. Thank you.